I've got a love-hate relationship with this machine back here. This video has been all about the hate. I bought this CNC machine and it may have been a huge mistake. Let's talk about why. First thing is the space. This thing is huge. It is a 4-foot by 4-foot machine. 80 to 90% of the cuts I make could have been done on a smaller 4-foot by 2-foot machine. Only get a 4-foot by 4-foot machine if you're 100% certain you can make use of all 16 square feet of cutting area. The company that sells this one also sells a smaller 2-foot by 2-foot machine. I've got no idea why you need a machine that small. There are better options if you need something that small. I know what you're thinking, 4-foot by 4-foot doesn't seem like a lot, but that is just the cut area. The machine is about 59 inches wide. Then running front to back, taking into account the stepper motors, it's about 58.5 inches. Plus you're going to need room for accessories like the emergency stop, a place to mount your computer, and a place to mount the control box for the CNC machine itself. So to make room for all that, I made the table a little bit longer. It's 63 inches this way and about 65.25 inches deep. But wait, there's more. You need access to all 4 sides for work holding and maintenance. You're going to be tempted to put this baby in a corner, but
nobody puts baby in a corner.
After about 6 months of use, I had one of these retaining nuts come off. That nut holds this ball screw to the stepper motor. It was the one on that side over there, so I had to move all my toolboxes, take apart my dust collection, just so I could get to it, burn 30 minutes of my life just trying to find the problem. That would have been easier if the machine were out here in the open where I could get to it. If you get one of these, it's going to take up at least 50 square feet of your shop space, and on top of that, you're going to need dedicated dust collection. At the very least, you'll want a 2-stage setup with a shop vac and a cyclone, plus a HEPA filter inside the shop vac. I've been running this Harbor Freight one with the cyclone for a couple of years now, so I just had to run some pipe work over to this so I can make it work. But still, that dust collector takes up space, probably another 10 square feet that I can't get back. Hang on a second, I gotta take a break from the video and apologize for that constant beeping sound that you're hearing in the background. They're building a subdivision behind my shop. Today's the day where all the trucks just back up constantly. Sorry about that, I can't do anything about it. Reason number 2 is the learning curve. This machine back over here requires you to learn not just 1, but 2 different pieces of software. The first one is Carbide Create. That's where you design and lay out your CNC projects and set up your tool paths. And then there's Carbide Motion. Carbide Motion is what actually controls the machine. Now the good news is both of those are actually free. You can go download them right now and see if you can figure out the software before you go and buy the machine. Now for me, I didn't find the software itself to be that complicated. The really hard part was learning how to design projects and to set up the tool paths. The only way to really figure that out is to just dive in and do it. But the software is just one small part of the learning curve. You've got to learn everything else there is to learn about running a CNC machine. These right here are some of the clamps you use to hold down your workpiece, and there's a whole art and science to clamping down your workpiece. The first few jobs you run, you're going to take forever trying to find the perfect place to position these things, but over time you're going to get faster and more efficient. You have to learn about the various types of bits that you can use in your CNC machine, and you have to learn terminology. We're not supposed to call these bits, we're supposed to call these end mills. Different bits do different jobs and have different purposes. This is a tapered bit. I used it for kerfing. This is your standard 1/4-inch bit, just like you would use in a router, and it's one of your main workhorses. This one right here has a rounded end. It's used for carving things like bowls. This is a diamond drag bit. It's used for engraving in plastic and soft metal. This is a V-bit. It's basically a chamfer bit with a point instead of a bearing. You can use it to chamfer your workpiece, or you can use it for inlays or lettering. It's pretty versatile. This is a surfacing bit. You need one of these for maintenance of your machine. You use it to make sure that your bed is flat. You can also use this like a planer to make sure your material is flat. These are all standard bits. You can find them in a drop-down menu inside the software. Just select them and you're off and running. These are not. You have to figure out how to go into the software and add the parameters for these bits before you can use them. These are all standard bits you can use in a router, but you can't call it a bit when you use it on a CNC machine. On a CNC machine, you have to call it an end mill. If you don't call it an end mill, some pedantic jerk on the CNC forums is going to chastise you for using the wrong word. It's an end mill. Ooh, fancy. Another complicated rabbit hole you have to go down are speeds and feeds. The feed rate refers to how fast the machine moves front to back or side to side or even up and down. And speed refers to how fast the end mill spins. The machine came with very little guidance as to what the appropriate speeds and feeds are. The bits that this company sells have defaults already loaded in the software, but those defaults are just horribly slow, so you'll have to figure out just how fast and hard you can push the machine on your own. Different materials and different bits all require different feeds and speeds. I'm slowly compiling a list of the feeds and speeds that I use every time I set up a job. If you get one of these machines, I'll be glad to share that with you. Maybe I can save you some of the time learning how to use the machine. Softwood, plywood, MDF, that's all pretty straightforward. You can cut pretty fast through that stuff. You can really wreck your project if you have the speeds and feeds wrong, especially for plastics, which have to be just right in order to get a good cut. Another challenge is 3D modeling. If you want to push the machine to its limits, you've got to learn how to model things in 3 dimensions. These are some beveled arcs that I made. I designed these in SketchUp and exported them as an STL file. That's the same kind of file format that 3D printers use. So if you can download STL files from 3D printing websites, you can cut those on this machine. But learning how to make 3D shapes is exponentially more difficult than simple 2D designs. Oh, and to top it off, the software can't do 3D right out of the gate. You have to upgrade to an add-on. More on that later. The third reason why you shouldn't get a CNC machine is the dust. This is the 1/4 inch end mill, and this is a standard saw blade. This end mill is going to kick up substantially more dust than this thin saw blade. You've got to do something about that for several reasons. Not only is the dust just generally bad for health and safety and a hell of a huge mess, if you don't get the dust out of your cut, this end mill's got to go back through it and recut it. That's going to shorten the life of your end mill and make things just more difficult for your machine. Now it's time to talk about the elephant in the room. Reason number 4 why you shouldn't buy a CNC machine. This thing is really expensive. Anyone who's bought tools knows that tools are just expensive. But most of the tools you have in your workshop are small expenditures that have added up over time. The CNC machine is going to require a large, massive upfront cost. And that is not fun. Not only that, there are a ton of add-ons that you just really need to go ahead and bite the bullet and buy when you buy the rest of the machine. This one back here has an upgraded router. It's a VFD spindle. That stands for variable frequency drive. Basically, the software can control how fast it spins. There's a probe you can add on so that you can easily set the 0 for the X, Y, and Z axis. You'll need some work holding clamps, and of course, you always need more end mills. You can never have enough. Some CNC machines come with a built-in table. This one did not. I had to drop some cash on some plywood and some 2x4s to build a big flat table to set it on. Some machines come with a computer. This one did not. I happen to have an old one lying around that did the trick, but you're going to need to spend at least $300 on a pawn shop computer to run the machine. In fact, you need multiple computers, an old junk one out in the garage to run the machine and one inside where you can sit down and do the design work. You cannot get away without dropping some money on dust collection. If you just go with a shop vac and a cyclone, expect to spend $200 or $300. That shop vac's gonna fill up fast. You'll quickly figure out that you really do wanna go with a full-size dust collection machine. Harbor Freight's got some good options for those, but man, the sky's the limit. You can spend thousands on dust collection. This machine came with free software, and that free software will do 85–90% of the projects that you're gonna need. But if you wanna push the machine to the limit and do 3D engraves, you're going to need to spend $140 a year for the upgraded pro version of the software. Even if you don't do 3D engraves, that software might be worth paying for because it has a hack inside it that will let you cut full sheets of plywood by just setting a full sheet of plywood up on the bed, cutting the first half, and then sliding it to cut the second half. Now you'll need an extra 4 feet of room on each end of the machine to do it, so it's going to take up even more space, but it can do a full 8 foot by 4 foot cut. Reason number 5 is waste. This 1/4 inch end mill is going to kick up a lot of dust. All that dust is going into the vacuum and it's never coming back. In order to make sure your workpiece doesn't fly off the table, you have to build a lattice structure out of tabs, and that's going to leave a little frame around every piece that you've cut out. I find that I can get away with about a 3/4 inch gap between pieces. Sometimes with curved pieces I can get a little bit closer, and I've got to leave 3/4 of an inch around the edge in order to have a space for the work holding clamps. So there's always going to be unused portions of your plywood or MDF that just get thrown away. Over time, you can learn how to be more efficient and effective and make less waste, but there's going to be waste and you can't do anything about it. It may sound like I'm trying to talk you out of buying a CNC machine. That is not the case. My goal is to give you information about the pros and the cons. And while there are plenty of cons, there are also a ton of pros. If you find that kind of information helpful, do me a solid and hit that like button. If you want want to help me make more videos like this, you can head over to Patreon, where you can join guys like Jonathan, Bo, Timothy, JD America, Joaquin, and Taylor. Even a $3 a month donation would mean a whole lot to me. A change of locations to talk about reason number 6, and that is the noise. This machine is stupid loud. Now, stepper motors themselves that actually move the machine aren't very loud at all. That's not the issue. And the spindle isn't any louder than any standard router. That's actually a little bit quieter than most standard routers. But then the end mill hits the wood and all hell breaks loose. It is a god-awful racket, especially if you're trying to push the machine fast. The faster the feed rate, the deeper the cut, the louder it gets. Then you gotta turn on the dust collection, so add in the racket from a shop vac on top of that. Trust me, you do not want to be in the room while the machine is running. If you're in the room while the machine's running, you absolutely need some kind of hearing protection. Reason number 7, this thing is slow, man. If you're doing simple things, if you just want to make some square cuts, this table saw right over here is a much better option. If you just got 2 or 3 circles to cut, the router with the circle jig beats it every time. Not only do the projects take a while, that box right over there with the curves, that was a 2-hour cut. It also takes a lot of time to set up the machine. You got to clamp down that workpiece and do it right so it doesn't fly off while you're cutting. Not only that, you've got to sit down at the computer and lay out the design. Now, I usually already lay out my designs anyways in something like SketchUp, but this has introduced an extra step for me. And that extra step takes time. It's part of the learning curve. You will get faster over time, but don't expect to start busting stuff out real fast right out of the gate. You got to figure out how to use the machine. So after you factor all that in, it is not going to speed up your workflow. The real advantage to the CNC is it frees you up so you can do something else while the machine's running. You can go inside, sit down at the computer, lay out the next project. One of the reasons why I bought this CNC machine is because I have grown to hate using the router and these templates to do projects. I don't enjoy standing at the router table all day with my fingers inches from the router bits. So I'd really hope that the CNC machine would free me up from the router table. The reason number 9 why you shouldn't buy a CNC machine is because it will not free you up from the router. And that's because you need to use tabs as part of your work holding strategy. The best way to get rid of those tabs is to flush trim them on the router. I just leave the flush trim bit in the router. Every time I'm finished with a cut, I gotta go through a 2-step process with one of these and this bit to get rid of the tabs. I've lost count. I don't know if this is reason 8 or 9. I don't guess it really matters. But the next reason why you shouldn't buy a CNC machine is, if we're being perfectly honest, you don't actually need one. For virtually everything you can do on a CNC machine, there's some other tool or some other method that will do the same job without the expense and the space taken up by the CNC machine. Anything artistic is better on the CNC machine, things like engraving your logo or carving and etching custom designs. The CNC machine is really good for repetitive action, but you don't have to have one to do custom work or do DIY projects. And that brings me to the single most important reason why you should not buy a CNC machine. And that's because you don't have a reason to buy the CNC machine. What I mean is, no matter what tool you're thinking about buying, only buy the tool if you know for sure exactly what you're going to use it for. If you're looking at one of these things and your entire thought process is, hey, that's cool, I bet I could do a ton of cool stuff with it, don't buy it. Instead, what you want to do is have something specific in mind, some cool thing you want to accomplish, and take the time to figure out if this tool back here will do that thing for you. Only buy it if it will. The right way to do it is to think about the cool thing you want to build first, and then think about the tool you need for the job. As for me, I've got a love-hate relationship with this machine back here, and this video has been all about the hate. To find out why you should buy a CNC machine, click on this video right up here. I'm Justin, this is the DIY Audio Guy YouTube channel, and I will see you on the next adventure.